We've had three Gilbreth lectures from university people, and now for our fourth Gilbreth lecture, this will be from a person from industry. Our next presenter, Richard Marks, directs the PlayStation Magic Lab at Sony Computer Entertainment, which focuses on using technology to explore new interactive experiences. He is credited as the creator of the iToy and PlayStation Eye cameras. For several years, he managed the R&D Special Projects Group, exploring man-machine interfaces and physical simulation research. He led the development of PlayStation Move and contributed to the design of the PlayStation 4 camera and DualShock 4. Most recently, he has been involved with Project Morpheus, PlayStation's virtual reality technology. He studied avionics at MIT before getting his PhD at Stanford in the Aerospace Robotics Lab. The title of his talk is Moving Innovative Game Technology from the Lab to the Living Room. Please welcome Richard Marks to the podium.
Before I start, I just would like to say how amazing, the previous three speakers are. You guys are really honored and blessed they got to see something like that. I was shocked at the level of quality, and I want to remind you that they're professors and they speak for a living in front of people, whereas I am not a professor, so I'm not so used to talking in an environment like this. So, bear with me here. A little bit about my background. I've always been involved with video games. I played them when I was a little kid, and my parents owned a video game shop right before the big video game crash happened in the early 80s. So I was the chief demo officer of our retail store, which meant I unwrapped every game the day it arrived and played it for people. But then I went to college and studied avionics, and I went to more college and studied robotics and computer vision. Computer vision is understanding what is in images and video, and then I went and worked as a startup, doing some of that for a while at a startup and then as a consultant. And then I saw the PlayStation 2 unveiled, and I joined PlayStation R&D, and I've been there for 15 years, so I've been there a long time. And I'll talk about some of the things I've worked on since I was there. So I'm going to go through a little bit of this quickly at the beginning. I think most of you, especially the younger people, understand that video games are a big business. There's a lot of people play them. But maybe you don't quite understand. I mean, something like I worked on iToy, which maybe a lot of you might not have even heard of, or PlayStation Move. $600 million for something you might not have heard of is a big revenue, and then over $1 billion for PlayStation Move. So these things that we do in the video game industry do have a big impact, both financially and they reach a really wide audience. And also we use really cutting-edge technology in the video game industry. So the ones I'm going to focus on or go over today are graphics and processing, display, and input technologies. And we have a unique platform with video games because if we try to push the bleeding edge and do something and we mess up a little bit, no planes crash, nothing like that happens. We get to experiment in a way that most other engineering disciplines don't get to do because we don't have to have 4 nines of safety and things like what we're doing. So we really want to always try to take new algorithms, apply them, see if it can generate something great for us. So we have that really unique, almost responsibility, I feel, to be doing that. So on graphics, that's when people think video games, the first thing that pops into their head is graphics. And when I joined, graphics was on this huge acceleration curve, and everyone was graphics all the time. And that's not my area, but what happened was, I think, we got to this, actually the last time I gave this talk was a few years ago, and so PS3 had this demo, Kara, which is an amazing video. You can look online and see a video of it. It's an interactive graphical demo. And then we got to the PS4, and now we have Uncharted 4 coming out. And you can see actually like the reflection of the world in his eye. That's the graphical fidelity that we've reached. And so if we knew that this would happen, that graphics would get kind of to a level where maybe the other parts of games would have to advance more. So the graphics curve was obvious, but we knew that other things would get left behind by it. But now actually we've come full circle. I don't have this on the slide, but with virtual reality, the graphics needs have exploded again. So now we need graphics to ramp again the way it was during these years. So graphics is no longer a done problem. It looked like we were going to kind of get to the level. I mean, that looks pretty photorealistic, but once you go to virtual reality, you need a lot more horsepower. I'll talk about that later. And then processing, all the graphics, all the consoles and phones have amazingly powerful processors in them now. And then even beyond that, we have the cloud at our disposal, so we can use a ginormous amount of processing power, do things, and then send it back. Maybe you've heard of PlayStation Now, which is our thing that we're doing with the cloud, where the whole game is running somewhere else and it's being streamed into your home almost as a movie, and then your input's sent back to the cloud, and then you carry on this dialogue with the cloud. And then, again, display technology has just ramped really fast, especially on portable devices, but also even in the home. We have 4K now out and amazing virtual reality headsets. So this area has really been on a rapid growth curve during the 15 years that I've been at PlayStation. But the area I focused on the most is input. And input, traditionally when I started, it was like, so here's a bunch of different input devices here, but when I started, it was kind of more like this. There was like, the simple gamepad. You put in all this, like button presses, and out this graphical thing happens, like a fighting game here shown. But now it's a little bit more like you have all this data coming in that we have at our disposal, and you can do all sorts of things. And then the PlayStation 4 has to make use of all this data to do something like, with all that processing power I mentioned before, to come up with maybe something amazing, like answer the ultimate question of the universe. But so in our lab, we've been trying a lot of different things on the input side, especially, and that's what I'm going to talk about. Maybe I'll just show a little bit of, I'll show a movie in a minute. But you can see we've tried different things. We've had college interns come in, and they saw Minority Report, and they wanted to make a Minority Report interface for gaming. And we have a lightsaber, and it was one of our guys who was working on input with that. And a lot of what I did is using camera technology, because that's what I studied in my college days. And then you can see one of the things I did, what we really believe in is prototyping very fast, trying things out, see if they work. So I took a DualShock, sawed off the ends of it, and then put a green ball on the end, and we could use that. And that's like basically the first PlayStation Move right there. And it was just done with a Dremel in my garage. So that's the kind of approach we take, just try things out, see if it's fun or it works out. And then those things all that I just showed you kind of turned into products eventually. Not everything we do turns into a product, but these did. So the lightsaber now actually it only shipped in Europe, but the PlayStation Hero had a green sword that you could interact with. PlayStation Move I mentioned before, and then did a lot other things. So let me just show, since I'm getting a little talking too much, let me show a video. This is my son. When I first started at PlayStation. So again, just using a camera plugged into a PlayStation 2, what would that enable? That was our question in our research. And so then we did a little bit of, computer game stuff. And so he was 3 years old. He's now 6'6" and trying to decide where he wants to go to college. So. But the thing we really were exploring with this was, this is an interface where he's moving a 3D object around, interacting with a virtual character, and he doesn't really, know how to use a gamepad at this point. So he was able to have fun and play with this. And that's my voice, by the way, as the witch. Let's see. Yeah, so he decided to start making kind of games on his own. There's no game here. It just kind of tracks and tries to sit on the ball. But he started, Let me skip ahead a little bit here. Yeah, so then we had another demonstration with these virtual butterflies. And he first thought it was neat that the butterflies kind of follow around the ball, but then he decided it was much more interesting if he hid the ball from the butterflies, and then... And so, there's some technology going on. We actually know where the ball is, so we can render into the Z buffer, so it looks like the butterfly's behind the ball. This is stuff I did really early on, and like I said, it turned into PlayStation Move eventually. And he's, a very cute kid, so it's... And then we had other demonstrations, which were more like what iToy did, using motion-based stuff. And so just, when you blend physics together with movement, it creates a really kind of entertaining thing to do. So here's water simulation mixed together with just a motion detection system. And so I told him he had to sit really still, which he did amazingly well. He just sitting there, not moving. But he could only last so long. So then, show this video here. Some other work similar, but pretty cool. So this is, again, in our lab, this is one of my colleagues who worked on water simulation. You can see back in the background there the water, but it's going to zoom in better. But basically using the exact same kind of tracking technology, just this color-based tracking, what could you do? And you see we zoom in onto what the PlayStation's outputting, and it's this augmented reality water simulation where you can pour water back and forth between the glasses. And there's something extremely gratifying about these physical interactions, which... Skip forward a little bit here. So I'm going to do the same thing now with 2 spheres. And another guy in our group was working on cloth simulation. So we're like, let's hook that up too. Cloth is cool. And so we had the cloth fall onto these virtual balls. And after you stop rendering the virtual balls, then it just looks like the cloth is falling onto what you're holding in your hand, which is cool. So this is the kind of things we're doing in our lab. And you can see, like, we had we used to take, the cameras were low res at first, so we had these really large tracking objects, the colored objects, like lightsabers. And then, well, you can see Jet Li came into our lab, and on the right, he was getting a tour, so he tried the demo, and he was too fast for our tracking system, unfortunately. But, and then we've shown these things at a lot of public trade shows. And on the left, actually, this demonstration of our original iToy, this game is Wishy Washy. That's actually Kaz Hirai, who's now the CEO of Sony. So he was a gaming person, and now he's elevated to the CEO of all of Sony. So what we had to do during this, we had to do a lot of the experiential stuff, but then we actually had to turn it into products. So the iToy is just a webcam, but the engineering choices we made were designed to match what we wanted to do with it for gaming. So for example, we wanted 60 frames per second, because if we go lower, we couldn't track even normal humans, not just Jet Li. So then we need to be able to track at a high rate, whereas most webcams were 30 frames per second at the time. That's just a choice we made. They could easily do it, they just weren't doing it because nobody cared. We needed a lens that was pretty wide angle because we wanted to fit a whole person's body in there. And then we also wanted it to work in lower lighting conditions. So all these things we could do, but people weren't necessarily focusing on them at the time because there was no application. So we matched the product to the needs of the research. Then after that, we started working on depth camera research, where we were using these time-of-flight based systems, which are really cool cameras. They also have these active light systems. And show you. I'm not going to go into too much of this, but just show you some of the kind of stuff we were doing. And we ended up, as a company, not productizing this. It was very neat. This was really expensive at the time when we were doing it. It did come down in price quite a bit. But so basically, it's just sensing things and how far away they are, and based on that, you have a threshold in front of you. So when you reach your hands out, then it knows those are something that's in front of your body, so it should track that. So now I don't need the colored object anymore. I just use my hands. And this is what Kinect can do. And actually, what we did with all this work, we worked with PrimeSense on a lot of this, and then we didn't end up productizing it, and Microsoft did. And it's actually not, I mean, in some ways it was a horrible story, but in other ways, actually our research showed up in the world, and it's not that bad of a thing to see your research still show up somewhere. Somebody benefited from it. So this was letting you cast magic spells with your hands. And I had access to an artist for like a very short time, and that was the spell the artist made. All the other spells after that are programmer art, and so they don't look like anything like a real graphic. So like an invisibility spell, that's a really good one because you actually just have to disappear. And so you saw me duck under the thing, so it's a little trick, but the reason I ducked is so that we could take a picture of the background while I was not there, and then you can alpha the live video over that background picture. Kind of a trick. Anyway. So there's, this is the kind of augmented reality use you could use a depth camera for. Another guy in our group, he was focusing on the more like motion capture things you could do with it. And this video you see on the right is stuff we showed at SIGGRAPH 2005, actually, right before we decided not to pursue this as a product. And there's really neat things you can do, again, by involving physical simulation with motion. So we just had this punching bag, a really simple physical thing, but you could actually get behind it and then kind of stand underneath it and lift it up with your body, which is, we didn't really program that in, but it just kind of emerged when we were playing with it. And then Matrix was out at that time, so we made a Matrix demo working. I'm dating myself here, but, So then, while we were doing the 3D camera research, we also had to worry about the real product kind of thing. So we made the PlayStation Eye, which is basically a better eye toy, better in every way. Wider field of view, no compression, things like that. So it's basically just a better version of the camera we'd already made. So it's kind of easy to make, but it gave us some benefits. We could do new things with it. So I'll just start this video. There's a game called Eye of Judgment that used it, and then this is my colleague in Europe, and he did some tracking research where it uses feature tracking. So when you reach into the dial, then it just sees anything that's moving in that dial area and tracks the features. Then you can free up the dial and move it around. And it's just very cool that you can do these kind of things if you have a decent camera image. Computer vision is really a very hot topic by the way right now. Anyone who's interested in computer vision, it's very hard to hire people in that area, especially because of all the things that are happening with wearables and augmented reality and stuff. Okay. So then we developed PlayStation Move, which is really, a lot of people compare it to the Wii. They say, oh, they just copied the Wii. But I showed you us tracking the colored ball. We've been doing it for a very long time before the Wii came out. We just hadn't productized it. They did kind of kick us into gear to productize what we had already done. So we combined this kind of inertial stuff like the Wii has with the colored ball tracking. So they get 6 degree of freedom tracking. And I showed you the prototype before, and we iterated and eventually come up with a product. So the way it works is the camera tracks the ball and knows where it is, and then inside there's angle-based inertial sensors to know the angle it's at, and then we fuse all the data together using a Kalman filter. So it's actually quite complex work that's done just to get this kind of toy to track around. But one of the things that we care a lot about is latency and precision. And that's really important for something like virtual reality. So we took this exact same technology in Move and moved it into what is now Morpheus. And so here, I'll just show you a video of it, because this is how much we cared. I mean, our engineers really, really wanted this to be good. So you can see we're augmenting graphics over the video to show how well it's tracking. This is live. So it just looks like the graphics are locked to where the ball is, but that's all being processed, and the latency is just extremely low. And that's what's really kind of making virtual reality work so well now these days. That's why it's gotten possible to do what people are doing. So next thing we worked on is PlayStation Camera for PlayStation 4. That's the name, PlayStation Camera. Not very marketing-y, but and so it's actually, again, just a better camera, but then we make a copy of it. So we have a stereo camera. And you can use that to get depth data by triangulation. And you can also use the two cameras independently. So you can have one at a very high frame rate and lower resolution, and then another one for higher res. We can use one in a low exposure for tracking the bright colored markers, and then another one at a higher exposure to track the human body or something like that. So we have a lot of flexibility by having this camera. And a wider field of view, and it's got a mechanical tilt now. I've always had the mechanical tilt, but it's got a built-in accelerometer, so we know what angle it's tilted at. And that's really important, so you don't have to calibrate it or anything. You set it on your TV, and then it knows everything about it. And so I also had a really good fortune of working on this cross-territory, cross-functional team that helped to decide what the PlayStation 4 should be. And there was it was a group of about 30 people, and we'd meet every so often, about once, every month, to figure out what the PS4 should be. And then the DualShock 4 had a similar process, only with a more distributed across the world team via phone mostly. And so that was really unique. And our thing that we'd already done before was the tracking of the colored stuff. So that completely was my group doing that part of it. But another thing we did is got to work with a team called the Asobi Studio in Japan, and they made the Playroom, which ships with every PS4. So a lot of the things that we'd done over the years in tech demos, they actually kind of brought into what they were going to put on the PS4 at launch. And so you can see the little robots on the ground, and the depth camera gives you where the floor is, so they can make the robots look like they really match in there. And then the controller's tracked so that you can fling the little robots out. Probably a lot of you have seen the Playroom before. And we got to show it on Jimmy Fallon, which was really cool. And see a YouTube video if you want to. Actually, I'll just do this. I don't have a video of that, but I'll show you the video we sent to Jimmy Fallon to see if we could, they wanted to show it on the show. It happened to be, like they said, you have to ship the video today, and it was Halloween that day. So I'm dressed like James Bond. That's why I don't normally dress at work like James Bond. But so this is just showing the video we sent to show them how it's tracking the controller around. You can interface with the touchpad on the controller. This is the Playroom that comes. Everyone who has a PS4 has this already. If they get the camera, they can use it. So we took all this kind of work that we'd been doing and decided we should formalize this into a group that's going to be responsible to do this. Now, we've done it kind of ad hoc the whole time. And we created this thing we call Magic Lab. And I've given a whole 35-minute talk on Magic Lab alone, and I don't have time to do that today. But what our mission is to push the boundaries of play. And we follow this experience engineering philosophy, which is really that we try stuff, prototype it, see if it's good, and then show it to people when we do think it's good, and we don't show people when it's not good. And we work a lot with other teams on it. So we also believe that in this new modern era, we need to share what we're working on. All the startups like to tell everybody, the Kickstarter, they tell everybody what they're doing even before they've done any of it. And big companies have not been able to do that historically. So we felt it's important for us to let people know what we're working on, because they're going to buy our products, maybe keep them for 5 years. We want them to know what's coming down the pipe. And my group is very small, only 4 people actually, and all this work you've seen is from those guys. And we have this kind of behavior we call the free electron behavior, which is we have no responsibility within Sony, but we communicate with a lot of different groups and move information back and forth between the groups, kind of the way electrons do. You have the nucleus, which is like the product group, and then you have these little electrons which fracture off temporarily and then come back with new data sometimes. So that's us. We have a lot of freedom, but no power, really. No mass. And so when you think of Magic Lab, maybe the thing first pops into your mind is like Willy Wonka or Harry Potter. And that's not wrong, but it's not exactly the flavor. This is what we think of more, like Iron Man's garage. That's more like what we... And so that's the brand we were going for with Magic Lab. And I'm going to skip the video of Magic Lab, but we have a video about that. And just show you, because the tech, I think, is still probably more interesting to you. So one of the areas we work on recently, which is not out yet, so this is now stuff that hasn't made it to product yet, is measuring the direction of what you're looking at. So there's a little yellow camera here you can see, and it knows what you're looking at. And the game studios were nice enough to let us take the Infamous game and hook it up to it. And so the red line is just an informational line to help you understand what's going on. That's not really there in the world. So he's sitting there, he's playing Infamous, but instead of using the right analog stick to move the camera around, he just looks where he wants to rotate the camera, the virtual camera, and it rotates. And then when you look at something and shoot the fire button, it shoots that thing. So you can actually be extremely precise in what you're shooting. You don't have to move a crosshair around. You can shoot something, and then it'll go up in the air, and you can shoot it again, so you can do what we call juggling of something, where you can just keep shooting the same thing over and over as it flies around the screen. And so eye tracking, we think, is a really powerful new input technology that's going to come in. People are starting to put it into tablets and other places. So this is one of the areas we're working on. And then, so also the other thing with eye tracking, we ran into this problem I was talking earlier about, is that there's some really neat subtle things you can do with eye tracking. Like you can have virtual characters and they know what you're looking at and they kind of act smarter than they would otherwise be. But if you're not told that that's why they're smarter, you wouldn't even know. You just think they're just smart characters, like AI got better. But so we had to find some other techniques, which like the ones we just showed you, where we could show how beneficial eye tracking could be in a very obvious way. Because if it's just a subtle way, it's not easy to get the products approved, actually. So now we found a lot of uses for eye tracking, and I think we're good to go. And then we have Project Morpheus, which probably a lot of you who are interested in technology have heard about. And it's our virtual reality headset. It's not out yet. We're still working on it. And the experience we're trying to enable really with virtual reality is presence. And presence means feeling like you're really somewhere else. And actually, I kind of have started to we have this argument of what is presence all the time, because it's such a vague term, and it's been around for a long time with virtual reality. And there's different levels, I think, of presence, almost like like an onion. The first level is you put these glasses on, and it seems like what you're seeing is physically believable. It's not moving or anything, but it's just a static, believable image. So you have a different image to each eye, so it's stereo. Then the next level is you move your head around and everything behaves like it's still there. So you still feel like the whole world is real because when you turn and look at something new, it rotates the right way. That's the first level of presence, and we're getting very good at that level of presence now. The graphics, like I said, need to get better, but the tracking is getting very good, so we can do that. The really hard part, though, is the next levels of presence, which is it's really the interaction side, where you want to track your hands, reach out into the world, do something. That's a very hard problem, and that's something that actually, I think for video games especially, we have to solve. Otherwise, it's like you're pretty much just looking at a really nice movie in virtual reality. If you can't interact with the world, it's not a game. And so our job as the game side of things is really to solve some of these interaction problems. So that's what we've been doing in VR in my group. We're taking our spatial controller background with PlayStation Move and figuring out how we can use it in other things also to kind of reach into the 3D world, grab the world, move things around, manipulate things, maybe move ourselves through the world. And then one of the really great things about having these kind of spatial tracking systems is you can see another person who's in VR with you, and you get a really rich feedback of what they're doing, and you really feel like they're present with you. So on the bottom right, we do a demo with JPL, where you can be in this kind of virtual asteroid landscape with this robot, and there's another person there, and it's fun just to see the other guy kind of hovering above the asteroid with you. And then on the left, we actually showed this on The Tonight Show. It was a very weird and crazy demo, it turned out. But we have two players in VR together, and you can see the hands being tracked in the head of the guy, and he can turn and he can wave to you, and one guy has a crossbow and he can shoot the other guy. It doesn't, really hurt him, but actually when the arrow hits him in his helmet, it makes a really loud sound, and the 3D sound works together. So having people, and when they talk, actually the audio comes from the right direction where the person is in virtual reality. So it's a very powerful feeling to be in VR. It's actually more social to be in VR playing a game than it is just to be playing a multiplayer game normally through the internet, because you don't have that presence of the person. You only have like an audio channel usually. So that actually concludes my talk. I will give you a little bit of future-looking stuff. It's really not a great idea ever to predict the future, but I'll give you a little bit of. I don't reach out that far anyway. So input is a really hot area still. So like I mentioned, computer vision is a really hard to find people right now. It's a really sought-after discipline. Virtual reality is obviously taking the world by storm right now, and at the Consumer Electronics Show was one of the biggest things shown. And augmented reality has got a lot of recent news, and Microsoft just announced HoloLens, which is they're not doing virtual reality, they're doing augmented reality instead. One of the areas we also think has kind of lagged behind is haptic feedback or force feedback. We were working with this really great company called Tactical Haptics, where they have this really simple, there's a lot of ideas that are really simple. So all this idea is it's these little things that slide up against your skin, just little linear motors that move this thing up and down. And all it does is pull on your skin a little bit, just a tiny bit. But that makes your brain think that something has weight to it, or that something is pulling on your hand, so it gives you an artificial feeling of weight, especially if you're in virtual reality or something. So you just have this little bit, and all of a sudden the sword that you're holding feels heavy, even though there's no weight to the controller. And then the last thing, actually the previous speaker talked about a little bit, is like with these wearables and stuff and all this data coming in, I think a lot of people are actually going to start using that data to do some life gaming. There's been efforts in the past a little bit. I think that the technology was premature and you couldn't do nearly as much previously as you'll be able to do in just a few years. And I think you'll see a lot of neat things about all this data from your body and stuff being incorporated into these kind of meta games of your life. And that's all I have to say. Thank you very much, guys. Yeah, I'd be happy to answer any questions about anything in the game industry, actually, if you're interested in anything, or engineering side of things, too.
What's your favorite video game of all time?
Yeah, so I'll give you the real answer eventually, but you know, currently I've been playing a lot of like things like Demon Souls and Dark Souls, very hardcore games that and I finished all of them. So I didn't finish the latest Dark Souls 2, but my favorite game of all time is actually Intellivision Sea Battle, and it was 2-player only, and I just played it with my father all the time, so that's my favorite. It's like a strategy game, kind of, actually. It's.
What did you work at? What did you work on before you worked at Sony?
Before I came to Sony, I worked at a startup company that was using computer vision for tracking. I used computer vision for tracking robots in my graduate work, and then that company that was giving us the computer vision tech actually hired me in order to start making a product for that. So my graduate work just turned into a startup company work, and then that company actually got bought, and then the company that bought us decided, oh, actually they didn't want us anymore, and they laid us all off. It was kind of a weird Silicon Valley typical thing where the companies don't really know why they're buying these other companies sometimes. And so they paid us to join and they paid us to leave. And then I wasn't sure what to do, and so I was a consultant for a while for different companies. I consulted for Sun Microsystems for a little while, and I consulted for Verifone for a little while. And my graduate work was in conjunction with the Monterey Bay Aquarium Research Institute, which was really interesting work for underwater robotics stuff. So that's also part of what I did before that.
Most of your presentation was mostly about the entertainment side of this. How can this be adapted to solve real life problems?
So that's a really good question, and it's a tough one. You know, as a company, our goal is to, you know, I think Google's motto is really good: don't be evil. And I think we should never crush any of these great efforts that are happening. And we try to lift them up when we can, but our goal as a company is entertainment focused. So we try to give out development kits to people who necessarily couldn't afford them to develop some kind of maybe educational games, but it's not our main area of focus. One of the things I do think is a lot of what we do in our research and stuff for video games enable other things. We lower the cost sometimes. We invest into display technologies and graphics technologies, and those end up enabling other areas and other disciplines. But I mean, I don't want to overstate. We are an entertainment company, and that's why that's our main area of focus. Lately, I've been a little bit more interested personally as I'm getting older and seeing how we can apply it more to education and things. Both of my parents are high school teachers, so.
Do you think this technology could eventually be transferred into movie cameras and film production?
Yeah, actually there was a graduate student who did really great work where he took the PlayStation Move and he mounted it onto a video camera for production work, and so then they would know exactly where the camera was, and then they could make the real-time visualization of CG while they're filming things, because they would know where the camera is accurately enough, and it was a low-cost kind of real-time system. Other people have applied a lot of the same computer vision work to movie production. Actually, the movie production people have specialized problems, and they tend to work in a different way where they say, I want to do this one shot, and I don't know how to do it, and then they'll assign their computer vision guy to figure out how to do that one thing. So he makes a lot of one-off pieces of technology. We tend to make more things that are product-focused, so we have a little bit different problems, but we share a lot of information at conferences like SIGGRAPH, for example.
What what do you think the possibility is like for this kind of technology to be backwards compatible? So if you're playing like with PlayStation Move, but playing like Half-Life 2.
Yeah, there are a few disciplines where you can take a new input mechanism and then kind of retrofit it to an existing game, but that tends to not work so well because a game is often designed a little bit around the input, and they know what they have at their disposal when they make the game. And so if you give them some new thing, so like maybe you've seen a game on the Wii where it looked like it was a button game and then they change it to be gesture-based, and it doesn't really necessarily make the game better. Whereas when you design something like Wii Sports from the ground up, you think, this is the controller we're designing this for, you make a really good experience for people. So with input in particular, I think it's hard to utilize it in a way. With output, it's a lot easier. You can take a new output mechanism and kind of, it doesn't change the gameplay typically, but input changes gameplay a lot. So I think it's hard. There's some games where it works, but it's one of the big things that happened with PlayStation Move is we didn't have enough content, I think, that made use of it well. And some of the content we did have was just these things where they tried to retrofit an existing game, and it didn't work great.
What do you see as the future of gaming?
Oh, gosh. Well, I think that I have to, I'll give you my, I've told this before, but I was not a big, excited person about virtual reality. And then I saw a few, I've been exposed to virtual reality for a long time. I saw it back in college and things, and it just never really excited me. And then I recently saw a few demonstrations which really did excite me. The fidelity of the graphic system, kind of blew me away that you could achieve. And then also what people have been starting to do with input mechanisms, seeing your hands in VR and things. There's some people working on that. And being able to reach into the world and really change things in a really physical way. There's just some really great experiences that I've tried that have made me like on fire about virtual reality now. So that's, I think, is going to be a big thing for the next. That's not a hard one because everyone else is saying the same thing. But and then I think, as I mentioned, some things we're doing with eye tracking I think will completely revolutionize the way you kind of interact with the games too.
What's the biggest challenge that you've had to face while working at Sony?
One of the questions I get a lot is like, well, why didn't you go and just do a startup and then you would own everything you've worked on? I mean, all these cool ideas. And that, I think, that would never have happened. Having Sony as kind of the enabler of all this has been why I've been able to do so many different things. However, it's a very difficult problem sometimes when you want to do something and you're at a big company and you can't, you don't necessarily control your own destiny sometimes. So I think that the hardest thing is to be able to keep moving forward when you have a setback where something is, we don't want to pursue that. For example, the 3D camera work, it was, crushing to have that say, no, we don't want to turn that into a product. But that's been the hardest thing, is to just stay moving forward.
What made you choose to work with Sony, PlayStation instead of Microsoft?
Oh, that's a great question. Well, I grew up, always interested in electronics and things, and Sony has such a wide, diverse set of things they do. We have a conference actually every year where all the parts of Sony, all the technology engineers show what they're working on, their research, to each other. And that's just amazing because Sony has such a breadth of things that they do. And I think that's one of the reasons I always have loved video games, and I wasn't sure I could bring myself to work at a video game company back 15 years ago because they were a little bit less, less established. But then a company like Sony, I thought was, that's a real company, so I would want to work there. And then when I got there, they do so many different things, and they have a strong, real passion for video games. I think some of the other companies are doing it more because it's a lucrative business, and I don't really feel like that's how Sony is, or PlayStation.
Well, Richard, thank you very much. Please join me with giving him a hand here. So I do want to say that virtual reality is one of the 14 grand challenges for engineering. So you're really right in the middle of the future. Thank you very much. Please allow me to read this certificate for Richard. It says, Richard Marks is hereby honored as a recipient of the Gilbreth Lectureship in recognition of the outstanding contributions to the field of computer science and engineering and presentation of his lecture on innovative interactive games technology at the NAE 2015 National Meeting. Richard, congratulations to you very much. I hope you have enjoyed this national meeting and this presentation for you, and I hope you will join me in thanking all the speakers for today's program. It's been quite an experience. And I thank all you students for coming and all your mentors for coming as well. And I'm very confident that a few of you have been turned towards engineering, virtual reality, robots, and so forth, nanotechnology, because you really have had a tremendous introduction to this wide range of an exciting future for engineering and sciences and your future as well. So thank you very much for coming, and we'll look forward to seeing you in the future as professional engineers yourself. Thank you very much.